All right, example 2. Example 2 says we have 3 objects in equilibrium. So as shown in the diagram, 3 masses are suspended by strings. The system is in equilibrium. No masses are accelerating. That's important. If mass 2 is 5 kilograms and the angles are 45 of theta and 30 of beta, determine the masses of M1 and M2. All right, so the first thing we're going to do is draw those diagrams. So I'm going to draw M1, and we don't know what its mass is. We do know the force of gravity 1 is pulling it down, and that's the mass of 1 times gravity, but we don't know what the mass of 1 is. And we know the force of tension is working up on it, but we don't know what that force of tension is. For M2, we've got a little bit more information. So for mass 2, we know that we have a mass of 5 kilograms. We know that gravity is pulling down on it, and we can say that's mass 2 times gravity. And we know that the force of tension is pulling on it upwards. All right, and then we have mass 3. And for mass 3, the force of gravity 3 is the mass of 3 times gravity, and we've got tension pulling up on it. No matter what we do with these, there's going to be no way that we can solve for M1 and M3 with this information given. This information isn't taking into account these angles right here and this system we have going on here in the middle. So we need to consider that system, and we're going to call that system point P. So we're going to consider point P. Our system is equilibrium. So if our system is in equilibrium, that means nothing is moving. It also means that all of the forces must balance out at point P. So let's draw a diagram of just point P down here. So we've got point P in the middle. We've got the force of tension 3 here. We've got the force of tension 2 going down. And we've got the force of tension 1 over here. And we know from the problem, or from what they told us, this angle is 30, and this angle is 45 degrees. All right, when we do this, we need to make sure it balances in both the x direction and the y direction. So there's going to be 2 ways you can solve this. You can solve this using your net force statements, which is the way I'm going to solve it. But you could also solve it with your sine and cosine laws. So if you did that, you would say that the force of T1 plus the force of T2 plus the force of T3 is equal to 0. And then you would use vector addition to get all those forces. All right, before we get started, a little something to help us out is going to be something to remember here. So, F, the force of tension 1, is equal to mass 1 gravity. The force of tension 2 is equal to mass 2 gravity. And the force of tension 3 is equal to mass 3 gravity. And we can say this because our acceleration is 0 meters per second squared. All right, so I said I was going to use our FNet statements. And because I need to solve in both the x and the y, I'm going to do x first, and then I'm going to do y. So I'm going to start out, and I'm going to find my y. So my net forces in the y direction are equal to the force of tension 1 in the y direction plus the force of tension 2 in the y direction plus the force of tension 3 in the y direction. All right. What is the force of tension 1 and the force of tension 3 in the y direction? So the force of tension 1 in the y direction is the sine of 45. And the force of tension 3 in the y direction is the sine of 30. But we can't forget over here, we said it was equal to mass 1 gravity. So we need to include those statements. I also need to decide on my positives and negatives. I'm going to say positive, positive, negative, negative. So my net force in the y direction is 0 because there's no acceleration. Equals the force of tension 1 sine of 45. The force of tension 2 is negative. Tension 3 is positive. Sine of 30. All right, now I need to take out the force of tension 1. So we said the force of tension 1 is equal to mass 1 gravity, sine of 45, minus the force of tension 2, plus mass 3 gravity, sine of 30. The force of tension 2 is straight up, so it's going to be our normal force. So we're going to be able to say that that's mass 2 gravity. So now I have 0 equals mass 1 gravity sine of 45 minus mass 2 gravity plus mass 3 gravity sine of 30. I'm going to move mass 2 gravity to the other side to make it positive. So I'm going to have mass of 2 gravity equals the mass of 1 gravity sine of 45. Oops, you can't see anymore. Plus the mass of 3 gravity sine of 30. All of my gravities cancel out. The mass of 2 we know is 5 kilograms. So I have 5 kilograms is equal to mass 1 sine 45 plus mass 3 sine 30. And this is going to be equation 1. Because this is my y. I can't go further than this because I don't know what mass 1 and mass 3 are. So this isn't going to do me any good. Now I need to come up with what equation 2 is going to be. So for equation 2, let's work everything that we have on our x-axis. So we're going to find the force net of the x-axis for equation 2. All right. So we've got the force of T1x plus the force of T3x. I didn't include T2x because it doesn't have any x components. It only has a y component. This is going to be cosine of 45 and cosine of 30. I said my net force is 0. It's an equilibrium. So 0 is equal to the force of T1 cosine 45 plus the force of T3 cosine 30. The force of T1 is m1g, so 0 equals mass 1 gravity cosine 45 plus mass 3 gravity cosine 30. And I just caught an error I made. When I did this, I didn't account for directions. So this force T1 cosine 45 is in the negative direction, so I need to make that negative here. That's going to also carry down here, so this is going to be negative. My gravities are going to cancel. So my final equation 2 is going to be 0 equals negative m1 cosine of 45 plus m3 cosine of 30. I'm going to add those two together. So I have 5 equals m1 sine 45 plus m3 sine 30. I have 0 equals negative m1 cosine of 45 plus m3 cosine 30. 5 plus 0 is 5. m1 minus m1, that cancels. Sine of 45 is equal to the cosine of 45 because we're working with the special right triangle. So those are going to cancel. So I'm going to be left with m3 sine of 30 plus cosine of 30. All I have to do now is solve for m3, and I'm going to get that weight of my third mass. That weight of my third mass is going to come out to be 3.66 kilograms. Since I know the weight of my third mass, I either want to plug it in to equation 1 or equation 2 to find the weight of my first mass. I'm just going to go ahead and plug it into equation 2. So I have 0 equals negative M1 cosine 45 plus mass 3 was 3.66 kilograms times cosine 30. I'm going to move this whole negative M1 cosine 45 over, and then I'm going to divide out cosine 45. So I'm going to get M1 is equivalent to 3.66 kilograms times cosine 30 all over cosine 45. So M1 is equal to 1.2 kilograms. My therefore statement is going to say, for the system to be in equilibrium, M1 is 1.2 kilograms and M3 is 3.7 kilograms. And that is the end of that problem.